Alkylation is a way to put an alkyl group onto a carbonyl compound with an alpha hydrogen. One method would involve treatment of the ketone, in this case acetophenone, with LDA, again that's lithium diisopropylamide. This would effectively fully form an enolate, and then the enolate could attack a suitable substrate like a benzylic, allylic, or primary alkyl halide, and workup would provide the alkylated acetophenone. Problematic in this methodology would be if there were any sensitive functional groups elsewhere on the molecule that could not tolerate the strong base, LDA. And secondarily, because LDA is a very strong base, you can't use mild conditions involving water. An alternative methodology to accomplish the same goal would be the Stork reaction. This involves treatment of the ketone or aldehyde with a secondary amine like pyrrolidine. Then, and that step would be done in acid and water. This will result in what's called an enamine, and the enamine is a suitable nucleophile where again it could be treated with a halide to alkylate it, and this would result in an iminium alkylated species, which is then hydrolyzed in acid to provide the alkylated ketone. Mechanistically, we would begin with nucleophilic attack of our pyrrolidine onto our ketone. This results in a species that looks like that. (1,3) proton transfer gives a species called a carbanolamine. And mechanistically, even though that looks like a far distance, it's not. The carbanolamine could be protonated on oxygen. This sets us up for neutral water as a leaving group. And to assist the neutral water, we can give it a push from the lone pair on the nitrogen, and that would result in that species, which is called an iminium ion. Loss of a proton, and the key proton is again the alpha H, alpha to what was originally a carbonyl, but now it's an iminium ion. And again, if that proton is lost, we've now formed an enamine. We can draw an equivalent resonance contributor of our enamine, which shows that it has significant negative characteristic on the alpha carbon now. By using the lone pair on the nitrogen, like so. You can use either form you want, and then showing your suitable halide, again benzylic, allylic, or primary, we could then produce an alkylated version. With our normal SN2-like mechanism. And the alkylated aminium ion is then hydrolyzed in acid. So the hydrolysis many ways to do this mechanism. First we attack the aminium ion with water. That neutralizes the nitrogen, putting the positive on the oxygen of what was water. And then we could do a proton shift to protonate the nitrogen of pyrrolidine. That makes it a good leaving group. And of course the next steps you've seen before. Push the leaving group off with the assistance of reforming our carbonyl. And then in our last step, lose a proton, resulting in release of the alkylated acetophenone derivative. This methodology is credited to Gilbert Stork, so it's enamine chemistry and or the Stork reaction. And again, it's a mild way to alkylate an aldehyde or a ketone that has an alpha hydrogen.